so here's the project for this video. This is the gear out of the fine adjust on the mill. You can see 2 teeth are broken. The pins that were drilled to lock it onto the other gear it attaches to were drilled into the teeth, which doesn't lead to a whole lot of confidence in that part lasting, even if I redo just those 2 teeth. So I decided to rebuild the entire gear. Took a little bit of time with my calipers and micrometers to get some measurements and come up with a chicken scratch drawing here for the part. I'm going to be making this out of a piece of 1018. I want to say it is a 3/4 inch or 5/8 bar. I don't recall off the top of my head, but this is the bar. It's plenty big enough for the gear, and I'm leaving it a little bit long and machining the gear into the end here so that when I chuck it up in the indexing head, I can use the tailstock to support it and cut it with a single point cutter that I built the other day specifically so I could do this job. Took some time, ground my own custom tool bit and everything, and hopefully it'll hold up just fine and be able to cut these gears. Alright, so I have my somewhat skeleton case on now, so that hopefully you guys can still hear me. So I've got the bar set up here, and I've got 1.5 inches sticking out from the collet. My first cut I'm going to do is I'm going to turn this down the length of the part here, or the length of the stick out, to 0.583, and then I'll turn the front end. Figured I could show you. I'm not getting blown out by this light here. Let's try that. So there's a 1/4 inch stem on each side, and then this thicker section here, I'm going to machine it like this. This is 0.366 or something like that. I have to look at my paperwork, but I'm going to turn the whole thing down. I'm going to turn this end to 1/4, and then I'm going to plunge in and cut back up this way and cut this diameter here. And when I get that done, I have a 1/4 inch collet. I'll machine this end down, stick it in the collet, and then do the finishing work on this side. And hopefully everything will go smooth. Oh yeah, also I figured I'd let you guys see that this is just under 1 inch. It's like 7/8 of an inch long. Again, I have my drawing over there for the exact size, but at this point it doesn't really matter. Let me get the camera turned and set so you guys can see what I'm doing here. So this first pass is going to be a cleanup just so I can get my DRO calibrated. See how close we got it with that. That's at 0.5835 according to the old calipers, so I'm going to call that good. Now, the next cuts, I'm going to use this carbide tool. Mainly because I'm going to have to make a precision depth of cut in. Actually, you know what I'm probably going to do, now that I think about it? I might just leave the piece a little long. Let's see.
since I switched tooling, my DRO is no longer set to the diameter. So that's at 350. Thinking I might take this in a little bit more. Overall length of the part is 0.866, so I could bring it back quite a bit more. I think that's what I'm going to do. The hell with having this cut at the right length right now. What I'm thinking is if I go a little bit further in, that'll get me away from the center point coming off the tailstock on the lathe or on the milling machine. So we'll come in. Alright, that's as far as I'm going to take that point right there. The width of the gear teeth is 1/4 inch also, so I'm going to come back over here. Actually, you know what? I need to set up my other tooling. I'm going to set up my other tooling and I'll bring you guys back. Alright, so a slight change of plans. I could not find the opposite tool holder to this so that I could make these cleanup cuts on this side, but I did find one of my old little replacement carbide tools that I've been using over on the mill for one of my fly cutters, and that's the right geometry that I need to get in there and cut the back side. So what I've done here is I've zeroed this edge with this front face here, and I'm just going to go back a little over 1/4 inch. I'm going to go about 275, and then I'm just going to make a plunge cut in, and then I'm going to come back to this side and plunge cut in where I think will be the best spot to bring in the other tool. So let me turn this down a little bit here. I'm sitting here cutting this, I'm thinking to myself, I think I'm going to leave it right there where it's at. And then I need to put a hole here in the end for the dead center on the tailstock for the rotary table. I love that cutter. Alright, so get some of this mess out of here. Let me see if I can find a little itty bitty center drill for that. Alright, I got a little, I think it's number 4 center drill here. And all I'm going to do is cut in until the next shoulder on that bit starts to engage it. attempt. Of course, I'm going to push it up here. Just a little bitty hole there with the shoulder so I can use the dead center. Alright, so got it set up in the mill. I've got the cutter here that I made and ground to attempt to cut this gear. Now this cutter will just barely miss the dead center here when it's all the way inserted. So I'm hoping that this will work. I'm going to be coming in from right to left and notching through. I've never used a cutter like this. I've never made a cutter like this. So I'm hoping that everything goes okay and all right. Get to 0 here. Alright, so that's locked down. Get this back out of the way so I can attempt to get everything set correctly here. And I think I'm going to have to move the camera to do all this, so I'll bring you back when I'm ready to actually make the cuts here. So I've got everything set up. Got the cutter in, zeroed, level. I'm at a depth that I think will work. And I've got my RPMs down. I can swing the camera around here. I'm on speed 2, which is 350. Since I'm single pointing it, I'm just going to make really slow cuts here, and hopefully the cutter works. Probably should throw some liquid love on here. Let's see how she does. Oh, you gotta be kidding me. Oh, man. Okay, well, bozo move. I didn't check the tension on this before I started cutting, and it's starting to wobble down, so all those teeth that I just cut are incorrect. So I gotta go machine up a new piece, hone this, and tighten the dang screws down tight enough so they don't slip again. Man, that is frustrating. Alright, set back up, turned a new piece out here. I have it set right where I think it needs to be to make this cut. And I increased the RPM from 350 to 600 because the last time I was trying to cut it seemed real jumpy. So I'm going to feed a little bit slower and see if the slower feed helps clean up the cut with a faster cutting speed. So here's the piece that this gear engages on. Is this? Let's see here, and it rolls in there just fine. It looks like it's seating pretty much all the way down, so I'm going to say it's good, and pull it out of here, get it cleaned up on the ends of the gear faces, and get the rest of the machine work done on it. Alright, back on the lathe, and I'm just going to clean up this front face here real quick. That cleaned everything up there. Now, get this one out, this one back in here, and actually finish off this front side. And of course, every time I need a brush, it's across the shop. Alright, looks like I'm going to have to do some deburring by hand here. But just have to go out here. That's too much of an angle with that one. I don't want to adjust my compound because of how it's set right now. Kind of how I want it to stay. What I could do, use this to slightly chamfer the teeth gear here. That looks good there. That's all smooth. Alright, now I need to get it cut off. Knocking my tools around here. All I'm going to do is I'm going to bring this up across here. So that this outside edge is even with that, and we got 0.866. And we'll just go 7/8. Part it and make sure you get everything set up on the right feeds and speeds here. Nub off of here real quick. Okay, now I need to measure the old gear. Has a hole through the middle of it, so I need to measure that real quick and then get it drilled and we'll be done. Alright, got it stuck in here. I went and checked, and the whole pass-through hole was a 5/32, but I don't want to go that big, so I'm going with 9/64. think that is going to do it.